the last class we have seen about one-dimensional arrays, right? So now we'll see how to write a two-dimensional array and what is the use of writing these 2D arrays. So array is the basic definition of array. It doesn't change. It is a collection of similar data items with fixed size. But uh, in some situations, we have to move on for this two-dimensional arrays because when the data that we have is in terms of this a matrix format or something like a tabular kind of data. In that situations, your one-dimensional array, it is not sufficient to store the data. So where in one-dimensional arrays, you will have only the list of elements. But where if you have something like this, so you have a class of students where you want to store the marks of all the students, and for each student, he or she will have some 4 or 5 subjects. So for every student, you need to store or you need to take the data of the marks of all the subjects. Okay, in that kind of situations, your two-dimensional array is required. So one-dimensional array is sufficient when you want to store the marks of one subject for all the 60 students in your class. But where if you want to store the marks of all the 60 students, so where each student is having some 4 or 5 subjects. In that kind of situation, you have to move on for two-dimensional arrays from 1D arrays. Okay, so this kind of data is, it looks like a matrix kind of data or a tabular formatted data. Okay, so that kind of situations you have to move on for two-dimensional arrays. See, in two-dimensional arrays, when you talk about two-dimensional arrays, we'll talk about rows and columns. Row and column. So in arrays, by defaultly, the indexes, they start from 0. They start from 0. It may be a normal one-dimensional index or a two-dimensional index, what multi-dimensional index. The indexes starts from 0 in the concept of arrays. Okay, so row number 0 and column number 0. Row 1, column 1. Row 2, column 2. So this means this is a matrix of size 3 by 3. This is a matrix of size 3 by 3. So where you will have 3 rows and each row will contain 3 columns. So total you can store 9 values. Where when you want to access any one of the values in this matrix, you need to identify, you need to point that value in the matrix definitely with the 2 indexes. Definitely with 2 indexes. The first index always represents the row number, and the second index always represents the column number. Row number and column number. So without this row number and column number, you cannot access the elements individually in the two-dimensional arrays. So row 0, column 0. So that means the first element in this matrix. Row number 0 and column number 1, second element in row 0. Row 0 and column 2, the next element in the row 0. So when you move to the next row, the row number changes to 1. And column number again starting from 0. And when you move to the next row, row number is 2 and column number again starts from 0. Okay, so this is how we will represent our 2D arrays. Okay, so to declare any two-dimensional array, we have to follow this syntax. So type indicates the data type, array name, and you have to specify the maximum value of the rows and maximum value for the columns. That means maximum I can store this many number of rows and maximum I can store this many number of columns. Okay, so this is a maximum number of rows and maximum number of columns you want to use in your two-dimensional array. Okay, so you have to specify the data type. So type means data type, array name. So what name you want to give to the two-dimensional array, and maximum rows and maximum columns in the square brackets. So arrays whenever you use arrays, we'll use a square brackets. Okay, see, look at the example written here, which is int is a data type, v is the name of the array, and here in this array I want to store maximum of 4 rows, and each row will contain maximum of 4 columns. Row 0, row 1, row 2 and row 3. And coming to the columns, column 0, column 1 and column 2. So this looks like a matrix of a 4 by 3 matrix. Okay, so is it clear about the concept of what as a two-dimensional array means? Hello,
Hello.
is it okay? So then after declaring a two-dimensional array, so we have to initialize the arrays, right? So this is how I will initialize my two-dimensional arrays. So two-dimensional arrays can also be initialized by compile time initialization and runtime initialization. Compile time and runtime initialization. See, first we'll look at how a compile time initialization happens, and then we'll write I'll tell you how to initialize a runtime initialization for two-dimensional arrays. So this is an example. These are the different forms of initializing a two-dimensional array at compile time. See, I'm writing a table of 2 rows and 3 columns. 2 rows and 3 columns. So that means total I can store 6 values. Okay. Out of these 6 values, the first element here it stores in the index 0, 0, 0, 1, 0, 2. And next element stores in 1, 0, 1, 1, 1, 2. So by defaultly it will store in this order. That means my two-dimensional arrays are by defaultly they store in row wise. First it will fill the first row, that is the 0th row. Then it fills the first row. Then it fills the second row, third row. Like that it will fill the elements. If I give all the values like this in between the square brackets. Otherwise, I can also give like this. All the elements that belong to the first row, that means the 0th row, I'm giving them in a separate set of square brackets. And all the elements which belong to the row number 1, I'm giving in a separate square brackets. Okay. So that means you can give directly like this all the elements in a single set of square brackets. Sorry, flower braces. Or else you can give you can separate all the row wise elements in a separate set of flower braces. So first set of flower brace will represent the elements belong to the row number 0, and the next set will belong to the row number 1. Okay, so look at this kind of initialization. So in this initialization, you can skip writing the number of rows here. You can skip the number of rows, but number of columns have to be specified compulsory. Number of rows will be calculated by the compiler based on the flower braces you give here. I have given two sets of flower braces. That means the compiler assumes, or the compiler calculates, the maximum number of rows are 2, because I have two sets of flower braces. Two sets of flower braces. So based on that, it will find out, okay, this two-dimensional array is having maximum 2 rows. But specifying the number of columns is compulsory. Specifying the number of columns is compulsory. You have to specify them for sure. Okay, got it? Next, look at this initialization. So maximum I have 2 rows and each row will have 3 columns. So that means so only 2 rows here, right? And each row will have 3 columns. Okay, so this is row number 0 and row number 1. And I am giving only 2 values in the first row. That means these 2 are filled with ones. Okay, you don't have this one, sorry. You have only 3 columns here. And I am not filling the last element in the row number 1. And in the second row, I am giving only 1 value and I am not filling the remaining 2. So by defaultly, if you make a partial initialization in any array, the remaining elements will be defaultly set to 0. If I make any partial initialization in the array, the remaining values are automatically filled with zeros. The same thing happens in my one-dimensional arrays also. I told you there also. If any array is having any partial initialization, the remaining positions are filled up with zeros. Okay. And look at the next one. I have maximum of 3 rows and maximum columns are 5. Two, 3, 4, and 5. Okay. So 3 rows and 5 columns. And what I'm doing here, I'm filling every row first element with zeros. What about the remaining positions?
All will be 0.
All remaining all will be by defaultly they'll be filled with zeros, because initializing one element with zero is also a kind of partial initialization. Okay, so remaining values also filled with zeros. Next, this one, 3 rows and 4 columns, and I'm giving 3 zeros. Automatically, all actually you can store up to 12 integer values actually, right? A matrix of size 3 by 4 means in total you can store 12 values, but you are only giving 3 integers. That means 3 zeros. What about the remaining 9 positions? They are also filled with zeros. Got it? So this is how you can initialize your two-dimensional arrays at compile time. Any doubts in this?
No, sir.
Okay, then I will move on to a runtime initialization. Suppose let us say I have an integer array like this, a table of 3, 4. So this is my two-dimensional array, and where I want to initialize this two-dimensional array at runtime. So when you want to initialize it with runtime, you need to write it with the scanf. That means you can write like this: ampersand a of 0 0. And next, scanf percentile d ampersand a of 0 1. Okay. Next, you can write like this: percentile d ampersand a of 0 2. Next, ampersand a of 0 3. So this will fill all the elements in the row number 0. In row 0, I can store maximum of 4 columns, right? In the same way, if I want to fill the next one, I'll write like this: ampersand 1 0. So this is for row number 1, 1 2, 1 3, 1 4. So like this you can write, but it will be very hectic for us when we have the two-dimensional array of size like uh, number of rows here is, sorry. So number of rows here is like 30 rows and 40 columns. So that means total how many values you can store? Row size is 30 and column size is 40. You can store 1200 values in this two-dimensional array. So every row will have 40 values. Such 30 rows we will have. So what I'll do, instead of writing them separately like this, so I'm not interested in writing all the reading all the things separately. So what I'll do is I'll write a for loop. For I is equal to 0, I less than 30, I plus plus. Okay. So again I'll write a nested for loop here. For j is equal to 0, j less than 40, j plus plus. Here I'll write percentile d comma ampersand a of I. So this is how I'll write a simple nested for loop for reading all those 1200 values in that two-dimensional array. I'm sorry, this is a table, right? Okay. To read all the 1200 values which can be stored in this table can be simply take input by these statements, by this nested for loop. Okay. So see how it happens. So what variables you have here? You have a variables like I, and you have another variable like j, right? So first it initializes your I becomes 0. 0 less than 30, true or false? 0 less than 30. Hello? Hello? Am I audible?
Yes, sir, the sound is slow.
0 less than 30, is it true or false?
True, sir.
So true. So when it is true, it will initialize the j variable. So j becomes 0. So 0 less than 30. Sorry, 0 less than 40 here. So it is also true. So when it is true, it will read a value and store in the location of this with I and j as zeros. So that means in this table you will have number of rows like this. 40 rows in each, sorry, 40 values in each row. So like this you will have. So first is row number 0 and column number 0, 0, 0. And next it will increment the j value. So j becomes 1. 1 less than 40. The condition is again true. And again it will read one more value and it will store in the location 0, 1. That means row number 0 and column number 1. So this value is already taken. Now this value. Again j plus plus. So j becomes 2. 2 less than 40. And the condition is true. It will again read one more value here, which is 0, 2. So this value will be taken from the user. So like that, it will read all the values. So when it is 39, so on j value will be true for all the values, and when it is 39, it verifies 39 less than 40. The condition is true again, and it will read a value for the row number 0 and the column number is 39. So now this value is taken, and now my j value again gets incremented. It becomes 40. It verifies this condition like 40 less than. Is it true or false?
False.
So the condition becomes false, and it will not no more execute the scanf. It comes out of this for loop and increments the value in my outer for loop. which is I plus plus. So my I value becomes 1. And this condition is verified now, which is I less than 30. That means 1 less than 30. The condition is true. Again, it will execute like this. The J value gets reinitialized to 0. So from 40, J again it becomes 0. So that means this will start reading the values in the row number 1. Like it will start reading the value for 1 0. That means this position. And next 1 1, this position 1 2, and so on 139. So when it is 39, again the condition 40 less than 40 fails, and again I will be incremented, so it moves to the row number 2. It again starts reading all the values which belongs to row number 2, like row 20 21 22 23, like that 239. So this is how it will read all the elements in the two-dimensional array with a single scanf, which is written in a nested for loop. Okay, you got it?
Oh, sir.
Huh?
Sir,
Hello?
hello?
You understood or not?
No, sir.
No, what you didn't understand? You tell me that, I'll repeat that one.
Sir, in and table 1 1. So what you did that
What?
in and table IJ.
IJ.
Yes, sir.
This will represent my I,
Okay,
and this will represent the J.
okay, sir.
Okay. So when it is 0 0, I value is 0 and J value is 0. So that means this position will be filled. First, my I J value will get incremented. I value is still 0 and J value gets incremented from 0, 1, 2, 3 till 39. And then it becomes 40 also. But the condition 40 less than 40 is false. So when this condition falls, without executing this inner for loop, it will go and increment the outer for loop value, which is I. So from 0, the value of I becomes 1. When I becomes 1, it verifies the condition like 1 less than 30. Yes, 1 is less than 30. So again, the J variable, it again will get initialized to 0. J variable, again it becomes 0. So it starts from 0 again. 0, 1, 2, 3 with I value as 1. That means 1 0, 1 1, 1 2, 1 3 till 139. So when the value of my J again becomes 40, the condition fails, and again the I value gets incremented to 2. So from 1 it becomes 2. And J value again reinitialized to 0. It becomes 1, it becomes 2, 3 till 39. Okay. Okay, I'll try to tell you with, I'll write an example program and I'll show you. Okay. Ash include stdio.h. See, first of all, I'll declare a two-dimensional array here. Hello, please mute your mic. So first of all, I'll declare a two-dimensional array like this. A table of, I'll say, a 2 by 3. Okay. So this is my two-dimensional array. So first what I'll do is, I'll read some values into this two-dimensional array and just I'll display those elements in the on the screen. Okay, I'm not doing anything. I'm just reading the values and displaying them on the screen. That's it. Okay. So first, the printf enter the elements in 2D array. So to read the elements here, you require a nested for loop, right? So to access any elements in the two-dimensional array, you require it. So first, my outer for loop will represent the number of rows. That means you need to iterate it for the maximum number of rows you have. And you have to write a nested for loop. That means the inner for loop with the variable j. So this will be iterated for maximum number of columns. I'll write scanf percentile d comma ampersand a table of I j. So this is how I'm reading all the elements in my two-dimensional array. Next. Excuse me. So just I'm trying to display whatever the values that were given here. Again, to display all the elements also, again you require one more nested for loop. So without this nested for loop, you can't access all the elements in a two-dimensional arrays. J less than 3, j plus plus. A table of I j. And after completion of every row, I'll say printf. So the reason why I'm writing this slash n here is after completion of every row, that means if I have two rows, after completion of first row, I'll make the control in to print in the next line. That means in a new line. After completion of row number 1, I'll make the control to print in the next line. So that means all the elements will be displayed in a row wise manner. First, it displays all the elements belong to row number 0. Next line, it prints all the elements belong to row number 1. In the next line, it prints all the elements belong to row number 2. So like that, it displays or it prints the values or prints the elements in row wise. I have some errors here. Undeclared I and j. I'm sorry. I have to declare the variables int I and j. These are the loop control variables. So successfully it was compiled. And when you run the code, see, it is asking to enter the elements in 2D array. So total, how many numbers you can enter here for a matrix or for a table of size 2 by 3?
6.
6 elements. Yes. These are the elements that were stored here: 4, 6, 9, 12, 10, 17. Got it?
Sir,
Yes.
sir, first number is 4, right? It taken as a row or as a column?
First number is
4.
hmm,
It taken as a row, right?
no, no. For every number, it will have a row number and a column number. For every number, you have to tell its row number and its column number. Otherwise, you can't tell a number in the two-dimensional arrays. Okay, see, I'll show you. So how many rows we have here? We have 2 rows and 3 columns, right?
Yes, sir.
This is row number 0, row number 1. And this is column number 0, column number 1, and column number 2. Right? Look, so when the first value is 4, first it will fill all the elements in the row number 0. All the elements in row number 0. That means first element will be filled here. Second element will be filled here. Next element will be filled here. After completion of all the elements in the first row, that means 0th row, then it moves to the row number 1. It fills 12, 10, and 17. Okay.
Okay, sir. Sir, is it possible to complete first as a column?
No, no. Is it clear up to this?
Yes, sir.
Any other doubts? Okay. Now we'll try to read values in a two-dimensional array, and we'll try to find out the sum of elements in each row. Okay. So that means if I have values like this, if I have a 3 by 3 matrix like this, so I want to print a sum of the elements in the row number 0. That means 1 plus 2, 3 plus 3, 6. 4 plus 5, 9 plus 6. 7 plus 8, 15, 15 plus 9. So these values I want to print. Okay. Say, look here. Hash include stdio dot h. So I will take a two-dimensional array like this. Say a of 3, 3 by 3. Okay. I have a loop control variables like I, j, and I also take a variable called sum for storing the sum of the elements. Okay. Okay, so for reading the elements, I require I is equal to 0, I less than 3, I plus plus. So maximum number of rows are 3. In the same way, maximum columns are j plus plus. Scanf, I'm reading a value, so storing into the location a of I, j. So is it clear to this point? So this is what I'm taking input from the user. Is it clear up to this?
Yes, sir.
Okay. Then what I need to do here? After completing the input, I need to start accessing all the elements individually, and I need to find out the sum of those elements. Right? So to access the elements again, I require a for loop, no doubt. I'll say I equal to 0, I less than 3, I plus plus. So this is for each row, right? So every time I'll calculate the sum. So what I'll do is I'll take a variable sum and I'll initialize it with 0 here. I'll try to find out the sum of all the elements in this row number 0. That means in this row. So in this row again, I want to access all the elements. So which elements? With the help of j, I will access j less than 3, j plus plus. What I'll do? Sum is equal to sum plus a of I. Sum is equal to sum plus a of ij. I'll just find out sum of all the elements in this row number 0. So first I'll calculate the sum for row number 0. Then I'll calculate for row number 1. Then I'll calculate for row number 2. Like that I'll do. Okay. So first, after completion of all the sum of the elements in row number 0, that means by the end of this inner for loop, I'll come out of this loop and I'll display a statement. That means in row number 0 is sum, right? So what is the value of the sum after completion of row number 0? Initially some value is 0. By the end of the first row, that means the 0th row, what is the value of sum? By the end of the row number 0, that means you are adding 1, you are adding 2, you are adding 3 to that sum. By the end of that,
6.
you are displaying that 6 on the screen, and your sum variable is also 6, right? Yes or no?
Yes, sir.
And when you are starting with the row number 1, will you add this 4 to 6, or you want to do something here? Are you interested in adding the values of this row to the previous row? No, I want to calculate the sum of only these elements, not the sum of the previous row elements. Previous row is already done. I have already displayed that on the screen. So whenever you are moving to the next row, immediately what you need to do is you need to reinitialize your sum value to 0. So that what it will do is from 6 it becomes 0, and then it will add this 4, and then it will add this 5. So 4 plus 5, 9. 9 plus 6, 15. So no other elements here. So it will display this 15 on the screen. Previously it has displayed 6.
15.
So now it has displayed 15. And after that, it moves to the next row. So again, when it is moving to the row number, that means I value is incremented. I value is incremented, it means you are moving to the next row. Whenever the I value is incremented, here I am initializing my sum value to 0. So again, freshly I want to find out the sum. Again, this 7 is added to this 0. It becomes 7. Again, 8 is added to 7. It becomes 15. And again, 9 is added to 15. 24. And there are no other elements. 24 is displayed on the screen. And you are making the I to move to the next row. But unfortunately,
24.
there is no other row exist here. So this is the end of your task. Got it? See, I'll execute and I'll show. See, enter the elements in the row. I'm just giving these values 1, 2, 3, 4, 5, 6. So sum of elements in row 0, row 1, row 2.
Sir.
Yes.
Hello.
Yes, yes, yes. Tell me. Hello.
Hello.
Yes, yes. Tell me. Someone is asking something. Hello. So anyone
Sorry.
have any doubt? Hello. Yes, someone. You have any doubts? You can ask. Otherwise, this is end of today's topic.
No, sir.
Okay. Okay. Then Narayana, do you have any doubts? Yes.